Hey, Aiken, my dude, how you been, my friend? I hope you're doing well, my good friend. Let me turn this down a smidge. There. Hopefully the music is not overwhelming. All right, let me switch to my camera thing. All right, there we go. My dude, Aiken, how you been, my friend? Are you doing well? I don't know how well you're doing after. I know that you know, Everton lost yesterday, so I'm sure, a little bit upset, but that's okay. Crazy things, man. What a week. What a weekend. I feel like it's already Friday. Can it just be Friday? I wish it was Friday. Hey, my dude, Mini Real, buddy, how you been? Are you at work? Or are you at work or no? By the way, Mini Real, how's the girlfriend doing, my man? I hope she's doing well. I don't know if you traveled last weekend to go see her or not, but hopefully she's doing well. Yep. Hey, Sneaky Weasel, how we doing? Yep. Good, good. Hopefully she's not too burned up. Testing printers, oh boy. Just what the doctor ordered. Let me check that there, Sneaky. Let me test that here. 8-2 number one. See. Okay. So you have to have let's see here. NP times 1 minus P must be bigger than or equal to 10. So if you're talking the first part of the question, is that what you're referring to, Sneaky? Yo, Yusuf, 46 days already. Man, I love your countdowns. I did figure out the Z-score stuff. Good. Part B? Okay, hang on. Let me just check my part B. Alright. Determine the mean of the sampling distribution. That one? Actually, let me change that up. I can't see jack stuff. Well, what's the mean there? How many people did you ask? You have a p there. Your p value is your sampling distribution, my dude. It's the same thing. So I'll show you what I have on my screen. This is what I got, bro. This is it. See, I got 0.2. And you gotta figure out your standard deviation there. Remember the formula there. Bleh, I can't even speak. So, remember the formula there. There was that formula. Where is it? Remember this formula here, Sneaky? Square root of, I can't wait to see you. Yeah, dude. Me too, Yusuf. 100%, man. I can't wait for it to be December and I could come see you, my friend. We'll have a great time. Dude, that's the standard deviation right there, Sneaky. If that's the formula. When do we have to find it? You have to find it, of course, when you enter into normal CDF. So what would you put down if P was greater than or equal to 0.84? What would be your lower, what would be your upper? Yeah, like normal CDF, right? They have 0.84, comma 1, comma mean, whatever P is, and then your standard deviation. Which would be using this formula that you see up here, Sneaky. That doesn't make any sense. So you're telling me that 0.16 is higher than 0.84? I'm not sure what you mean by that. It's 84% to 100%, right? Sneaky? That's what I'm trying to say. So if it's 84% to 100% is 0.84, comma 1. That's what you gotta roll with. Because if it's 0.84 or above, that's what the question asks you. So that's what you got. That's what you got to run with there. Does that make sense? Well, you're using proportions, my dude. That's why you're using 0 and 1. So you're using percentages in that particular section. That's why it's 0 and 1. Alright, cool. Alright. We'll start here in a few minutes, ladies and gentlemen, with some Math 120. Got some new stuff here today. I'll switch back to the main cam. We'll come back to this. Alright. Alright. Good stuff, everybody. Good stuff. Hopefully we get to be able to understand a bit more of its importance. Get that material down 100%. Got a little bit to do here today, so drag over the book. Can't use this too much, but it is what it is. How's everybody's weekend? Hopefully everybody's weekend was absolutely fandibly fantastic. All right. Alrighty. If you can believe it. If we get through chapter 10 here today. Let's get through chapter 10 here today. I was quarantined all week. I don't know. Did you catch COVID there, Alex? Or were you in contact with somebody who had COVID? I know my mom and my sister have been quarantined for like 2 weeks. So, pretty much. Yeah, that sucks, dude. I'm still not allowed to go back home according to my sister, so until she gets tested herself last time. She just wants to make sure she has a negative test. So, yeah, it's no bueno when you have to sit in isolation all day. Are you feeling good though? Or everything okay on your end, Alex? I just hope you're feeling okay, that's all. I was exposed to COVID, so I couldn't work for last week. I lost. Oh man, that sucks, Sneaky. Oh man, that stinks. Yeah, were you Hey, Goldmash, how are you, my friend? I hope everything's going well. I'm doing fantastic, Goldmash. How are you? So, Sneaky, you were you feel weak more than anything? I really can't stand for more than 10 minutes. Okay, man. Well, I hope you're having a seat and you won't get too dizzy with the material I'm presenting to you. That's what I'm hoping for. Sneaky, were you exposed by a coworker or something like that? Yeah, sometimes. I was fine. Both tests were negative, but I had quarantine based on our company's thing. Yeah, you know, that's... Companies can't take risks anymore because you could literally have an entire shift literally be out for an entire week or so. His coworker, best friend? Aw, man. You know what? Sometimes you can't help that. You know, even people get the vaccine. Sometimes it's just, you know, you can't avoid it altogether. Vince, my dude, how you been? I'm doing great. How are you? I hope your weekend was good. Here's what I'm hoping for: that everybody gets through their COVID issues, you know, and they get that stuff out of the way. Go on or live our lives, live hopefully comfortable lives. It's important. I don't wish COVID on anything. Hanging in there, okay. By the way, don't forget, guys, that today is the deadline for the homework and the test there. So, if you haven't, pretty sure some of you are already aware. Yeah, that's a thing. So don't forget, 11:59 tonight. 11:59 tonight. That is when everything is due for the next chapters. Guys, we're almost done. If you want to know the most remarkable thing, we are almost done, which is, you know, quite amazing. So you can think of it this way: we finished up. There you go. Finished up sections 10.1 and 10.2 last time. We could finish up chapter 10 here today, and then we have chapters 11 and 12, and then that's it. That's the whole book. Chilling yesterday, they did a maths test, got the results. Yeah, there you go, Goldmash. Very nice, 95%. Wonderful. Rabia, hi, Professor. Can I meet you? Yeah, of course you can, Rabia. You want to meet on Discord after class, Rabia? Just let me know. If you want to meet on Discord after class, we can talk. If you have questions and stuff. Good job, Goldmash. Very nice, very nice. 95% is legit. That's what I'm talking about. For the final test, how many questions are on it? I forgot. That's a great question. I made it a while ago. I don't know. I want to say I put 50 on it or something. I don't know. Something dark side. Something. I don't remember. Let's see. What did I put? Oh, 55. 55 questions. Yeah, 55. There we go. 55 for the final. So, I put 55 for the final there. Again, it's just an amalgamation of all the other 3 tests that we have and kind of putting it together. So, that's essentially what it is in a nutshell. There ain't anything special about it. It's just like, Hey, it's the same questions, just I took a little bit from each one and I kind of put it together. That's okay. That's why I gave you 10 hours of which to do and a save for later option. You don't have to do them all at once. Although, obviously today being the due date, that's kind of a thing. So, if it takes you a little while, that's fine. That's why I have the save for later option, because I'm not intending for you, even in the final, I'm not intending for you guys to finish it all in one go. Alright, if you want to, you can, but it's not really the intention here. So, 55 questions, or heck, even 30 questions, is quite a bit to do in all honesty. So, I mean, I'm not going to sit here and say, oh yeah, you know, this is going to be really, you know, really easy to do all at once. Like, of course not. I don't have any, you know, there's nothing to really say about, hey, this is going to take you everything. I'll have to do that next time. Well, I mean, I did say that from the very beginning there. I must have put one question test. That's okay. Goldmash, it's fine. You don't need perfection. I could tell you right now, I'm the last thing from perfection. 95 is good enough. I think that's just great. Means you knew exactly what you were doing. Yeah, Vince, you just gotta give yourself some time. You know, I give you a lot of time of which to finish, but you gotta give yourself some time. You know, as opposed to go to the procrastination station. Just saying. Alright, ladies and gentlemen, we are going to get started here for today. Let's do some intros. Let's get started. Let's do this. Alright, ladies and gentlemen. Okay, let's get started today. Alright. Alright, I'm out of breath doing that. Let's try that again. Okay, let's get started today. Welcome back. I don't even know what happened there. Welcome back to Tuesday. Have a nice weekend. Alright. Have a good one, Goldmash. Alright, everybody. So today, just as a friendly reminder, remember that the test and the homework for all of chapters 5 through 8 is due today at 11:59 p.m. Alright, so for today, ladies and gentlemen, I'm going to ask you guys a question. So last time we did finish up section 10.2. We are on track here to finish pretty easily. I'm going to ask you guys a question here because I know some of you are probably working on several things. Here, I could post a Discord link for you, Rabia. There you go. Okay, so let me ask you a question here. Do you guys want me to do one section today or 2 sections today? Would you guys like me to do 1 section today or 2 sections today? Because today is usually with stuff. So Vince says good with 2. We'll take a little poll here. I'll go 1 or 2. Oh, Q is not a number, so that's probably bad. We are pretty ahead there, so that's doable. I know not a lot of people are here today because people are working on the last minute assignments and tests and stuff. Trust me, it's not like I don't recognize that. You're like, It's like, I know where people are at. Alright, so 4 people said 1, and 1 person said 2. Okay, so we're gonna go with 1 here today. That's perfectly fine. we're gonna continue moving forward here within chapter 10. Alright, if you haven't worked on the again, I suggest finishing up those assignments and stuff after class. That'd be pretty good. Alright. Okay, in any case, let's take a good look here at the big board. Let's see what we're working with here today. Take a look. Chibs, can you raid? Yeah, I can. Yeah, I can, Yusuf. I can raid Lee. I can definitely raid Lee. 100%. I gotta finish my class first, but yeah. Yeah, Yusuf, I could do that for you. No problem. Okay, so today, ladies and gentlemen, we're going to continue moving forward here with hypothesis testing, okay? That's what we're going to be doing here. All right, so last time, we did a couple of sections here. Number one, first of all, kind of laying down the groundwork about, what hypothesis testing was all about. A lot of information dump, talking about the conclusions about hypothesis testing. We also did one thing with hypothesis testing. All right, we did actual hypothesis testing with, say, a mean given to us here. Or actually a proportion, excuse me, a p. Alright, so that's what we did here in section 10.2. Today, we're going to be doing section 10.3. Alright, and so let's go ahead and take a look here and talk about the questions and see exactly what we need to do in order to solve for these guys. Okay, so let's go ahead and do that right now. Alright, so let's look at question 1 here on the handout. Question 1 says, what assumptions must we make to do a hypothesis test of a population mean when the population standard deviation is unknown? Okay, so one thing important to realize of what's going on here in this particular section for hypothesis testing is that we will be given a population mean here of some variety. Whatever that is, alright? Doesn't really matter. However, what we will not know here in these problems is that we will not know a population standard deviation. However, in order for us to do hypothesis testing, we of course have to follow some assumptions here. Let's take a look at those assumptions right now. First assumption that we have to make is that whatever the sample is, again, as normal, it has to be a simple random sample from or a randomized experiment. So again, it has to be purely random, and again, everybody must be chosen at random and have an equal likely chance of being selected. Alright, letter B, the sample has no outliers. So, the sample has no outliers, the population from the sample is normally distributed, or n is bigger than or equal to 30. So, one of these three assumptions can be true. Essentially, either the sample has no outliers, okay, again, the population is just normally distributed, probably the easiest of the three to satisfy, or again, n or the sample size being bigger than or equal to 30. That is, again, a sufficiently large enough sample size in order to conduct a hypothesis test. Although, maybe in some cases that may not be possible to have a sample of 30, so that's why we have the other two conditions that we could possibly satisfy. And then finally, letter C. The sample values are independent of each other. Of course, one sample can't influence another sample in any way, so pretty normal standard stuff. Alright, now, let's move on to the second question here, which is, of course, the big meat and potatoes of what we're going to be doing here today in this section. All right, so question 2. How do we perform a hypothesis test using the p-value method when the population standard deviation is unknown? Okay. Let's take a look here at the first 3 steps. Now, the first 3 steps here shouldn't be anything brand new, okay? These first 3 steps are the same first 3 steps that we discussed here last week when we first introduced hypothesis testing. So step 1, determine the null and alternate hypotheses. All right, this time though, at least from the perspective that we're going to be looking at here in these problems, is we are going to be looking at specifically the population mean. Okay, so for the null hypothesis here, we're going to have the population mean here that we're going to state. All right, so that's why I put mu here, which is again, notation here for population mean. All right, so that's going to be our null hypothesis. Of course, we have our alternate hypothesis, which is either less than, bigger than, or not equal to, again, meaning left, right, or two-tail type of tests. All right, and of course, we state the type of test here in step 2. Again, we always want to state this as a separate test. As we saw last time, We want to do that here for the sake of the calculator. All right, when we go ahead and compute this p-value, we need to use that fact there. And of course, step 3 here, stating the level of significance. All right, again, we use that as a comparison tool at the very end of the problem. All right, now having said all that, of course, we have, once again, let's go ahead and take a look at an example. All right, and let's see exactly how we can work with those first 3 steps, and we'll move on to the test stat and whatnot. All right, so we'll just, first and foremost, just get used to these problems. Really not too hard, but again, let's just make sure we have this right. No, come on. Good. Okay. All right. Let's look at number 13. Yeah. Okay. Let's look at 13 here. All right, 13 says, ready for college. All right, the ACT is a college entrance exam. ACT has determined that a score of 22 on the math portion of the ACT suggests that the student is ready for a college-level mathematics. To achieve this goal, ACT recommends that students take a core curriculum of math courses, okay, some random math courses, Algebra 1, 2, and Geometry. Suppose a random sample of 200 students who completed this course set of courses results in a mean ACT math score of 22.6 with a standard deviation of 3.9. Do these results suggest that students who complete the core curriculum are ready for college-level math? That is, are they scoring above 22 on the math portion of the ACT? We're going to do letter C here. We're going to use the p-value approach at the 0.05 level of significance to test the hypothesis. All right. Let's do this. Let's do letter C. We're going to do a hypothesis test here. Let's go over each step here. Oops. Right. So step 1, let's state the null and alternate hypotheses. So the null hypothesis here is we want to figure out the population mean. All right, so according to this question here, what is the population mean here? What is the null hypothesis? What is H0 going to be? What's that population mean going to be here? Again, that's what it represents if we go back to the guy here. Okay. Can anybody tell me here? What? Let me go back to the book here, because you obviously knew that. What is H0? What is the population mean is going to equal here? Oh, yeah. Thank you, Alex. Thank you. That's right. We had issues with that last time. You're right. Thank you for reminding me. Is that better? Is that better, Alex? Can you read that better? Let me know if that's still too small. I'll make it bigger. Yes? Okay. Okay. 22.6 says Vince. Not quite. Not in this case. Think of it this way, Vince. Population mean. All right, population mean. So you're talking about everybody. What would be your population mean here? Remember, that's the perspective we want to look over, right? Ah, that's correct. Very good. That's right. So that's why I write down population mean here, because it is indeed 22. There's 2 ways to look at this. Number 1, the ACT determined a score of 22 is they're ready. Or, again, you could look at the last line. Are they scoring above a 22 on the math portion of ACT? So that should be a giveaway there. It's like, okay, well, 22 is going to be my population mean here in this case. All right, well, we need a alternate hypothesis as well. What's the alternate hypothesis here? Let's take a look here. What's the alternate hypothesis here, guys? What is H1? What is the alternate hypothesis? Is it less than, is it bigger than, or is it not equal to? Less than, bigger than, or not equal to? Well, one of those two answers is correct. Let's take a look. It says that is, are they scoring above a 22 on the math portion? So in this case here, yeah, it would be greater than. That's right. All right, so correct, greater than. Okay. So that's okay. It's all good. All right, so we found the null and alternate hypotheses. That's perfectly fine. All right, so let's move to step 2. All right, so we found the important part here. What type of test do we have? Do we have a left tail, a right tail, or a two-tail test? Do we have a left tail, right tail, or two-tail test? All right, we do have a right tail test here. Good. All right, very nice. All right, that's correct. I have no idea why my icons have popped up on my screen, but we'll work with it. All right. Does that sometimes, it's weird. All right, anyway. Okay. All right, step number 3, we state the level of significance. All right, so let's do that. All right, so the level of significance here is given to us specifically. Again, we don't need to find this. 0.05, yep. So again, this is just given to us in the problem. You don't need to find this at all. No point in finding it. You just go ahead and use it. And use it for the sake of this problem. All right. So these are the first 3 steps that we have here. Again, the pretty similar same 3 steps that we discussed here last time. All right, is also applicable here in this problem. All right. So again, just hopefully giving you a friendly reminder about what we did here last week with those first 3 steps. Now, of course, what's the key difference between this problem and what we did last week in the second section with the proportions? Of course, it comes down to the last 3 steps because, of course, in order for us to make a conclusion here, we're going to need to find some pieces of information. Let's go ahead and go back to the handout here. Let's go to step number 4 and step 5 and step 6. All right. So let's go to step 4 here. Step 4 is we have to compute the test stat. Now, once again, just to let you know, again, remember that the test stat here for the proportion one back in 10.2, the last section, was pretty complicated. Now, this was not as complicated as that one, but once again, I do want to stress that you don't have to memorize this formula at all. We're going to, again, use the calculator to find the test stat here, but if you do need to at least confirm your answer, you do have the formula here in front of you. So we do need some pieces of information, though. Just obviously, we do need pieces of information 100%. So what pieces of information do we need? Calculator or no calculator. Well, let's go ahead and go over that here really quick with the test stat. We have the sample mean minus the population mean divided by the sample standard deviation divided by the square root of the sample size. And that's how we get the test stat here. Now, what that means is that we also need to state, first and foremost here in step 4, we need to state some key pieces of information, that being, of course, not only the population mean, which we've already found to be 22, but we need the sample mean, the sample standard deviation, and the sample size. We need all of that in order to do our proper calculations. So the sample mean, sample standard deviation, and the sample size. Let's go over each one here. Let's go over the sample mean, sample standard deviation, all right, and the sample size, N. Sample mean. Okay. Let's find these 3 values. Let's take a look back at the book here. Okay, so taking a look back at the book here, can anybody tell me what is the sample mean according to this problem? What does the sample mean according to this problem here? 22.6. That is correct. Okay, good. Let's at least state that here. 22.6. Sounds good. All right. What's our sample standard deviation? What's our sample standard deviation here? All right, 3.9. All right, that's correct. Very good. And what's our sample size here in this case? What's our sample size? All right, very good. It is indeed 200. That can be found right here. Suppose a random sample of 200 students who completed this course set. All right, very nice. All right, so now let's go ahead and talk about what we're going to do here next. We need to go ahead and find the test stat. Of course, we're going to also find that along with the p-value here. We're going to go back here. Now that we have all the given information that we need, let's talk about what we're doing next here, especially, of course, on the calculator. Bring up here in a second. All right. So, we're going to go ahead and use the calculator here. Specifically, we're going to use the function on the calculator that's called the t-test in order to determine the p-value. So we're going to use t-test here in order to determine the p-value. All right, and then we'll make our conclusion based off of that. And this same conclusion here is the conclusion that we made last time. Again, if the p-value is less than the level of significance stated in step 3, all right, then we reject the null and accept the alternate. Otherwise, we accept the null and reject the alternate. All right, so let's bust out our calculators here. All right, so when everybody has their calculator out in front of them, please type "got it" in the chat so we know when to start. So if you have your calculator there in front of you, I'll give you a moment or so. All right, Victoria's got it, Alex got it, Stinky and Vince. Sure, I don't know who else is in the chat, so hopefully everybody's got their calculator. I'll give another there. All right, Thodal's got it. Okay. Good. All right, I'll start in about 5 seconds, 5-10 seconds. Just making sure everybody's got it there, and then we'll move forward. All right, let's go ahead and move forward then. Okay, so first things first here, everyone. We're going to go ahead and hit the stat key here. So let's hit the stat key. All right. We're going to go over to tests. Do I want to become famous? Oh. Why, yes, I do. But can you be famous first? You can be famous for being added to the band list. It's amazing. All right, so now, we go scroll over to tests. We want to go down to t-test. All right, so we scroll down to t-test here, and there we are. We're given here. Now, all of you should be on this sub-menu here, okay? Doesn't matter if you have old school or new school calculator, this is what you should see here. Make sure that we're here in this case. Now, in this particular instance, we are given the mean, the sample mean, the sample standard deviation, and the sample size that go along with the population mean. So we're going to go over to stats here because we are literally given stats here in this problem as we've stated here in step number 4. Find out what this test stat is in just a moment. Okay, and we need to go ahead and fill in these blanks. Okay. All right. So, let's go ahead and put in these blanks here. So the first thing that we see here is, of course, the population mean. That's where we're going to put in 22. We're going to put 22 into that first spot there. Next one here, we'll put 22.6 for the sample mean. And the sample standard deviation of 3.9. We also have n here, which is our sample size of 200. And we have our sample standard deviation here. Not sample, our type of test here, which is a right tail test. So this is, again, remember how it works on the calculator. This is the two tail, this is the left tail, and this last one here is your right tail test. And we'll go ahead and hit calculate. All right, and let's go ahead and hit enter. And this is what we should see here. All right, please type in "got it" in the chat if you got exactly this value here. Thody, you have to... Alright, Thody, you gotta do this. If you go over to t-test here, Thody, you have to go over to stats first on your inputs. So the very top option there, Thody, you have to go over to... Yours is highlighted on data right now. You have to go and scroll over to stats and hit enter. And then you can put in all the values that we have in here. Yeah, you'll always be given two options there. Alright? And put in your numbers, and then... So put in your numbers there, and then make sure you have the same result that I do. So again, 22, 22.6, 3.9, 200, and make sure it's highlighted on a right tail test. And then hit calculate once you're done. So we do get a test stat here. Our test stat here is going to be 2.1757. Alright, cool, cool. So that's going to be our test stat here. That's the first number you see up here. And then we also have a p-value here. We have a p-value here of 0.0154. Okay. Well, that's what we're given here in this case. Okay. Or found, I should say. Alright, any questions about that? Any questions? Everybody, hopefully... Alright. Lodi's back, so that's good. Any questions so far? Nope. Alright. Okay. Now, no? Alright. Let's make sure everybody's on the same page here. Alright. So, step number 6 here. We have to make the comparison here. So again, we just have to ask, is the p-value here, 0.0154, is the p-value here less than 0.05? Which is our level of significance. Yes or no, is 0.0154 less than 0.05? Alright. So, yes, okay. So what's our conclusion then? If it's less than 0.045, what is our conclusion? Reject the null and accept the alternate. That is correct. Okay. Yep. Alright. Okay. Okay, very good, very good. Any questions about this problem here? Any questions? Everybody pretty good with that? Hopefully? Question mark? Um, Hang on a second. What has happened? Give me just a second here. Okay. Alright. Just making sure everything is okay. For some reason, everything kind of stopped here for a moment. Alright. Okay. Nope. Alright. Good stuff. Alright. Let's focus on the next question here. Do the next question. Not this. Alright. Okay. Let's take a good look here at number 20. Let's see which one. Wait, you have a question? Go ahead, Vince, my friend. Of course. More than welcome to ask a question anytime. What does the test stat number do for us? Well, it's actually that's a good question here. The test stat actually is essentially the z-score that you find here with the given information under that particular distribution. So if you notice, the p-value is like the probability value, and the test stat is basically essentially with the given test that you're given. That's essentially, if you say right tail test and you do the test stat, you're basically finding the area to the right of that particular z-score. If it's like a left tail test, you take the area to the left of that test stat or that particular z-score. If you take the two tail test, you basically will find two tests. You'll find those test stats there, and you'll find the areas to the left and right there. That's essentially what that test stat effectively does. You basically, that test stat for the two tail will be the positive or negative of that z-score, and then you find the area to the left and right of that. So yeah, so that's what the test stat will allow us to do. Even though we're finding this automatically, we let the calculator do it for us. That's effectively what it does. Actually, it's a good question in another regard, because although we're not doing it here today, Vince, in the next section, 10.4, we do have to find the test stat manually. So we don't have a choice, unfortunately. So we're going to have to find the test stat manually, and we're going to be going through that process of finding that area, or at least making the proper comparison. Because we won't be able to, unfortunately, find the p-value here in the next section. So we'll be using the test stat in a different capacity in the next section. So cool. Alright. So let's take a good look here at let's do number 21, why not? Alright. Alright, so 21. The mean waiting time at a drive-thru of a fast food restaurant from the time an order is placed to the time the order is received is 84.3 seconds. A manager devises a new drive-thru system he believes will decrease wait time. He initiates the new system at his restaurant and measures the wait time for 10 randomly selected orders. The wait times are provided in the table. Alright, so here are the 10 wait times here. Alright, now, first and foremost, before we go ahead and do anything, alright, let's go ahead and first go through our steps here. So let's do our null hypothesis here. What is our null hypothesis here, according to this question? So we can at least answer that right away. What's our null hypothesis? What's the population mean time of an order from start to finish? 84.3. Okay. Right. So 84.3 is definitely our given go-to. Alright? 100% right. Alright. Now we're going to do a particular part here. So let's go ahead and take a look at that. Alright. So he does a new test. Okay, he does a new test. He says he wants to decrease wait time. All right, that's what he wants to do. All right, he believes this new drive-through system he believes will decrease wait time. Hey Connor, how you been, my friend? Good to see you, my dude. Is this new system effective? Use the 0.1 level of significance. Alright, so what's our alternate hypotheses here? How you been, Connor, my friend? I hope you've been well. So what is the alternate hypothesis here? Good. Man, I've been very good, Connor. I've been very good. Been fantastic, my friend. Absolutely fantastic. What is the alternate hypothesis? Less than 84.3. Okay. Very good. That is correct. Alright. So again, the reason why it's less than 84.3 is because he wants to decrease the wait time for waiting for a meal. This is actually a pretty good question. So, for several reasons. I'll talk about it. Gotta lurk a little bit. I'll tell you the practicality behind this question once we're done with it. There's actually a significant practicality to it. Alright. Let's go to step 2. What type of test do we have here, ladies and gentlemen? What type of test do we have here? Left tail test, that is correct. Good. So I'm going to try left tail test. Excellent. Alright, good beans. Alright, and we're given a significance level here of 0.1. Okay, good job. Alright, let's go to step 4. Alright, now in this case here, unlike the last one, we were given the sample mean and sample standard deviation. The only thing that we do know here in this particular instance is the sample size. The sample size here is going to be 10. However, the rest of this we do not know. Okay, so what we're going to do here, of course, is we're going to have to do it the alternative method here in order to find the test stat and the p-value. So let's go ahead and go through these two guys here together. Let's do it. Alright, so let's take our calculators out again. Alright, I'm going to move this stuff to the right side here. Actually, take that out. Move that off to the left side. This to the right side. Okay, so let's take out our calculators here. Let's hit the stat key. Let's go over to tests. We'll go down to t-test. We'll go over to this time though, we're going to go over to data. Alright, so we're going to go over to data here. Because this time we do want to actually use a list. Alright? Now we can put in some values here. Actually, let's do that first. Actually, I should have done that first. Alright, hang on a second. Alright, everybody hit second in mode. Let's quit to the main screen here for just a second. I do need to enter in a list of some kind now, don't I? Alright, let's hit the stat key here. Let's go to edit. Alright. Again, we're going to use the list here of data in order to enter that into our t-test. That would be helpful. So let's highlight the list here, L1. We'll hit the clear key, and we'll hit the enter key to clear our list. Okay, so what I would like you to do next is to go ahead and enter in all the numbers that you see here on the screen. Okay. Okay. Now, before I move forward here, I would like you to tell me if you got, if it's entered in. So just type in yes if you've entered in all your numbers in your calculator. All right, done. Everybody else okay? So Vince and Alex are okay. What about everyone else? I want to make sure that you've entered this in correctly. Sneaky, Victoria, Thody. Sneaky, yes, okay. How we doing? How we doing, the Victoria and Thody? Are you guys okay? Want to be sure everybody's on the same page here. No. What I should have done, I apologize, Victoria. You should enter in the list first before we do the t-test. That's why I'm going back and starting from this point. It's my fault, Victoria. That's my bad. So first, let's enter in the list of actual values, and then we'll do the t-test part. Okay? Sorry, my bio class is now. I forgot to do the homework. Yeah, I remember to do that homework, my dude. Hopefully you're following along a little bit. All right. Let me know once you got all the numbers entered in there, Victoria. Okay, done? Okay, cool. All right. Now that everybody's kind of got that in, we're going to go ahead and hit the second key. We're going to hit the mode key. All right, so we'll hit the second key and the mode key. We'll quit to the main screen. We're going to hit the stat key. We'll go over to tests. We'll go down to t-test here. All right. Now remember, in this particular case, we want to make sure that we are on data. Okay, so go over to data and hit enter. All right, so make sure you go to data and hit enter. So we should have this list of items here in this case again. So we should have a population mean, a list, and a frequency, and the type of test. All right. So first and foremost here, underneath data, we want to go ahead and put in the population mean. The population mean here was 84.3 according to our problem. So let's lower that down. So 84.3 was our population mean. Our list should be list 1. Again, if you don't see list 1 here, you know, let's say it's something different. Just hit second and 1 for list 1, because that's the list that we used here to enter in all our data. Okay. All right, making sure we're okay. All right, our frequency should never be changed. It should always be 1. All right, so make sure that it doesn't change. It should always be 1, and we should be fine with that. And then finally, we do have our type of test here, which in this case is a left tail test. So being a left tail test, again, we're going to highlight the middle portion here and hit enter. Then we want to go down to calculate, and let's see what we have. Okay. Okay, so these are the values that we should have here in this particular instance, just like so. All right, so let's put in our test stat here. Our test stat here is going to be negative, oops. It'll be negative 1.3102. And then we have the p-value here of 0.1113. Okay? That's what we have here in this instance. Let me see if I can change that a bit. Alright. See if that works. Alright. Hey, howdy, how we doing? How you been, my friend? The hair be looking questionable. What? Really? I mean, not much there to be questioned, to be honest. I gotta impress. Look too much like an egg? I believe. What did you want it to look like? A basketball? Everybody's head looks like an egg. I'm doing good, my friend. I'm doing good. Doing absolutely fantastic. All right, everybody, type "got it" in the chat if you got these same answers on your calculator that you do. That I do on the screen here. All right. So, let's go to step 6, as Vince has pointed out here. Ah, very good. Got 1 hour of sleep. Well, that's not good. I'm sure the time difference had a lot to say about that. So is 1.113. All right. Went to school. Jeez. All right. Good, good. So then we ask the question here. Is 0.1113, oops, I don't want to say bigger than, less than our level of significance of 0.1. So is 0.113, less than 0.1? Well, the answer to that is no, it is not. Comes really awfully close, but not less than 0.1 here. So, as was stated here by Vince earlier, this is correct. We're going to go ahead and accept the null hypothesis and reject the alternate. Now, admittingly, this has some real-world implications, at least a minor one. Maybe a minor one or a major one. Okay, let me throw this scenario out here. This is actually true, and they ran this similar type of test here, a hypothesis test, and they said, all right, they made a comparison, right? So they we'll actually look at a problem like this a little later on in chapter 11. It's like chapter 11 or 12. But they made a comparison here, and they said, all right. McDonald's did a comparison. They said, okay, well, what's the waiting time if we had 4 separate lines, which they used to do in the past at Mickey D's? And what's the waiting time in order to get served if they just had 1 line and 4 separate registers? And then you would just call the next person up. And they found out that the standard deviation of waiting time for someone's meal was significantly was significantly, the mean time here of waiting, excuse me, was significantly less if you had one line and 4 registers as opposed to 4 separate lines. And so that's why if you go and walk into a fast food restaurant, thanks to hypothesis testing, why you see in fast food restaurants, why you see one line and many registers as opposed to like many lines and with one register for each line. Like I said, it used to be in the past, used to be one line for one register, but now it's many registers for one line. So actually, by far and away, was one of the best things that could happen in the study. Excuse me. Hold my apartment. So, all right. Any case, but yeah, that's actually something. If you've ever walked into a fast food restaurant, yeah, that's actually how it is today. That's the reason why, was purely doing statistical testing and seeing exactly how fast you can get people in and out of serving you your food. So think of it that way. Real world effects in real life using stats. My dudes. All right. It used to look like, let me see if I can bring up a picture. This is like old school McDonald's. This is, when I used to work at Mickey D's, it used to be kind of this way, for the most part. It's like super old school Mickey D's. Let's see if I can find it. I don't know if I could find it. I'm not sure if I could find an old school picture. It's like, it looks kind of like this, where it's like you have one line for one, and then one line for another. You get the general idea. I don't think that's too hard. Actually, let me get your opinion about one thing. This is actually probably they made this decision based on a couple of factors, but what do you guys think about the touchscreen things that you could do at McDonald's? Like you touchscreen your order. Do you find that to be more convenient, or do you still like to tell a person behind the register your order? What do you guys think? You still like having the cashier put in your order, or do you have like the touch screen putting in your order? What do you guys think? Where is it, man? Why am I losing this? Alright. I feel like I'm losing a battle here. Not even sure why. There it is. Alright. Touchscreen note. If I'm in a hurry, the touchscreen's the way to go. Yeah. More convenient when there's a long line of people waiting to order. Yeah, that's true. Yeah, I mean, I went to, like the other day I was over in Elgin, actually, ironically. And I went to the Steak and Shake, and they were all like, yeah, they no longer do the, yeah, now because of the coronavirus and stuff. They no longer do the, the in-person order. They have the touchscreens. It's the first time I ever used a touchscreen because I rarely walk into fast food places anymore. Because usually I just go through the drive-thru. But it's the first time I used that, and I was like, man, this is actually a lot better because I can take my time and do my order. I was really happy with the touchscreen. So I don't have to be like, I don't know what my options are. I can actually view my options. So I found it to be super convenient in a lot of ways. Yeah, especially that's true, Victoria, when there's a long line. Yeah, it's super helpful. All right, so that is going to be, ladies and gentlemen, I want to point that out here. This is going to be the end of chapter, not the end, the end of section 10.3. Not the end of chapter 10. We got one more section to do, but the end of section 10.3. Are there any questions over section 10.3? Any questions whatsoever? I need to modify this. Go. Any questions, you guys? All right. As you know, you have until, all right, you have until 11:59 tonight in order to finish. Okay, so don't forget you have until 11:59 tonight in order to finish. All right. Yeah, just 10.3 here for today. All right. If you want to keep on track with the stuff, that's perfectly fine. All right. Thank you very much, everybody. You guys are absolutely fantastic. Now, I don't know if you're still here, Rabia, but we are going to talk over Discord. Okay, so if you're still here, Rabia, we'll talk over Discord here, and we will certainly discuss any issues you may have. We'll do that in just a moment. Okay, I do need to switch over to my other cam. Or, I don't really have another cam, but another thing. All right, we're gonna go ahead and raid a channel here since I was asked so kindly. So let's raid a channel. I'll raid my dude Lee Hersit, who plays FIFA. If you guys wanna just pop in and say hello, please feel free to do that. All right, that shouldn't be too bad of a problem. Rabia, I'm gonna see you on the Discord here in just a moment. Okay. All right. So please be on the lookout here. I will be there in just a moment. All right, everybody, let's go ahead and raid Lee here. Let's start this raid, and we'll raid him. And you guys can check out some. If you guys like FIFA, you guys can certainly check it out. Let's raid him. Here you go. Ba-bam. All right, everybody. Thank you so very much. I appreciate everybody here. Thank you so very much. And as always, everybody, stay safe, stay healthy, and most importantly, stay sane. Have a great one, everyone, and we'll see you later. Take care. Bye.